we were saying then that the trapezium, already guys? So trapezium, an example of a trapezium is in fact the windscreen of a car or the window on the car door. Okay? And so the trapezium will have this particular shape here. It has a short side here. It has two slanted sides like this and has a long side like that. Okay? And then sometimes, of course, it looks like the car window here. It looks also like this. See it here. Short side here, like that. So the ability to recognize the trapezium when you see it, okay, is important. Okay? Now with the trapezium, let's look at the different sides that it has. There are always two arrows. Sometimes the arrow is not there. If the arrow is not there, then you're going to tell you that it's a trapezium. Otherwise, if they just draw the shape, they will put the arrows there. And those two arrows means that the lines are parallel. Now, too many times persons will think that parallel lines are equal, not in all cases. Okay? So I don't usually tell students that parallel lines are equal. I usually say that parallel lines are lines running in the same direction, but they never meet. Now, you have parallel lines that are equal. For example, the parallel lines on a square, or the parallel lines on a rectangle, or a parallelogram. Those parallel lines are equal. But to say that parallel lines in general are equal, that's a false statement. Because here, these two lines are parallel, but yet against that, the bottom one is longer than the top one. Now, we usually label the trapezium the parallel sides A and B, and of course, we label the height H. Okay? Same thing over here. This side here is H, and here is A and B. And bear in mind that the orientation of the diagram can change. So even though I've drawn it on the board like this, doesn't mean that when I give you stop. I think it's still recording. No, it's recording. It's still recording. I don't know what happened, but it's still recording. It's still recording. It's still a number. I'm sure I just saw the numbers moving. Like it's moved. 40. I don't know. But it's fine, it's recording. Alright, so bear in mind that the orientation of the diagram can change. So even though you see I draw it like this on paper, when you get it on a quiz or on an exam, when you get it on a quiz or on an exam, I may turn the diagram the other way. I may turn it like this. Right? And I can turn it any direction. So your ability to recognize that it's a trapezium without being told that it's a trapezium is going to be important. You have to recognize that the two lines that are running in the same direction are going to be your A and your B. And again, as I've said before, height can be misinterpreted as it's something that is always vertical edging. Height doesn't have to be vertical, because if the orientation change, then height can become horizontal. And height, depending again on the orientation, it can become very oblique. So don't think that height has to be vertical. Now there's a formula for this. Okay? We're not proving the formula, so we give it to you. Area is equal to A plus B multiplied by H divided by 2. And that's the formula for the area for trapezium. Now, a little bit of positivity. The formula is given to you on the formula sheet at the front of your question booklet. And I find most of the times that those formulas on CXC are mostly like they're irrelevant. It's like most questions don't come where you require those formulas. But those are the ones that CXC gives you, right? And so this is one of them, the area of the trapezium. Okay? So because CXC gives you the formula, I'm also obligated to give you the formula in the quiz. I also find students don't really have a challenge using the formula. They have a challenge remembering when to use the formula and in which diagram. So you guys are going to have to work on that, knowing when to use this formula. Now we're going to be working two questions. One, in which we have to use the formula to find the area, and one in which we have to reverse the formula to find either a parallel sides or the height. Okay? Remember, in all the examples that I've taught you so far, every time that I've taught you how to go forward, I've also taught you how to go backward. When we were doing circumference, I taught you how to find circumference, and I also taught you how to find radius. When we were doing rectangle, I taught you how to find the length, and I also taught you how to find the area. And we all know that reversing is always a challenge. You know, reversing a car versus driving the car forward is, reversing the car is more of a challenge. So always going backwards with the formula is always a challenge. So take this example for me. This simple example. Write this down for me. Find the area of a trapezium. I'm giving it in worded form. Find the area of a trapezium. Find the area of a trapezium with parallel sides measuring, with parallel sides measuring, with parallel sides measuring 6.2 centimeter, with parallel sides measuring 6.2 centimeter, with parallel sides measuring 6.2 centimeter and 11.4 centimeter. And 11.4 centimeter. Find the area of a trapezium with parallel sides measuring 6.2 centimeter and 11.4 centimeter, and the height of, and a height of, and a height of 4.5 centimeter, and a height of 4.5 centimeter. Okay? So that's not too challenging. Again, sometimes the question is worded where there's no diagram to look at. And then of course, other times you may see the diagram with the measurements on it. So for this here, you're being asked to find the area of the trapezium. So you need the area formula. And I've always encouraged you, time and time again, when you're doing these questions, do not try to guess. When you guess, you get inconsistency. When you don't write stuff down, you make mistakes. When you make mistakes, it costs you. And you're going to make the mistakes early, which prevents me from giving you any marks. If you make a mistake early, I can't give you any marks. Even though the process is right, one error, and then that's it. So area is equal to A plus B times H divided by, say here, 2. So the A and the B represents the parallel sides, which in this case, according to the question that I just gave you, is in fact 6.2 plus 11.4, all multiplied by H, which is what? 4.5, and then we divide the answer by. It's a very simple application of PEMDAS. Very simple application of PEMDAS. Work what is in the bracket first. Now, what does bracket imply, Kelsian? Bracket implies multiplication. So therefore, once you have worked out what is inside the bracket, then the result of the bracket multiplies what is on the outside. So if I add 6.2 to 11.4, it's looking like 17.6 multiplied by 4.5 divided by 2. At this stage, you're free to type it in your calculator as it is. Can somebody confirm that? She said 39.6. Can somebody confirm that? Can somebody else confirm that if she's correct? Yes. She is 39.6. And that is the area of the trapezium. Very simple. Nothing too challenging here. Right? Once you get all the necessary measurements. Now, where it becomes a challenge here, right? And you don't get these very often, but like I said, if I just come here and give you the area of the trapezium, just like that, you can do this all day, all night, and never get a question. But what happens when I reverse the question on you? What happens when you're not looking for the area? What happens when you're already given the area? So I'm going to do this in a diagram form here. Okay? I'm going to draw a trapezium, say like this. And inside the diagram, I'm going to put, say here, 84 square centimeters. I'm going to put right here, say, 2.5 centimeters. I'm going to put, say here, X, Pardon me? I'm going to put here, sorry, I'm going to put here, say, yeah, I'm going to put 2.5 centimeter here. I'm going to put, say, here x, and I'm going to put, say, here 7.3 centimeter. Okay? And the question will therefore go ahead and say, find the missing side. That's all it's going to say. Find the missing side. Now when you look on a quiz paper or an exam paper and you see this sort of situation, bomb diagram, there's no information at the top, right? Or they might be, I might say to you that the diagram below represents a trapezium, or the diagram below is a garden, that is a garden in the shape of a trapezium. I can say whatever. And the information on the diagram is that inside here measures 84.84 square centimeters. At this edge here represents 2.5. This part here represents 7.3, and that side here is missing. That's the side that you're going to calculate. Now, this is where the challenge comes into students. Which side is which side? What do I call A? What do I call B? What is X? What is the 84? Which letters do they represent? Now, this comes back down to you understanding what the trapezium looks like. And so if we can go ahead here and label our sides from now, can we safely say that these two sides are the parallel sides? Can we? Do you think that they're the parallel sides? Are they the lines going in the same direction? They are. Not true. This and this are going in the same direction, but they will eventually meet if you extend them. So that and that could never be the parallel sides. This and this is the one. So anyone can be A or B. It's up to you. So you're going to call this A and you're going to call this one B. What does the 84 represent? Very good. So it represents what? A, and therefore this automatically represents what? H. Now we have successfully labeled the diagram. We know which letter represents which number. We'll go ahead and do what? What's the primary thing here? Right down here. So that's A plus B multiplied by H divided by 2. We're going to plug inside the formula. There's no reason for you to guess. When you guess, you're going to get inconsistent results. The formula tells you what to do. Jay, heads up. The formula tells you what to do. It tells you if you must add, it tells you if you must multiply, it tells you if you must divide. Now, area is 84. So that's 84 goes underneath the A, and we together collectively chose A to be what? 2.5. So that's 2.5 in bracket here, plus we chose B to be what? X. Very good. And we chose the height to be what? 7.3. I'm going to divide that by what? 2. There's a very different approach to the question then. Because what you find then, Brian, is that you're not allowed to add 2.5 to X. Why is that? You're currently on the topic of algebra, aren't you? And you learned in algebra that unlike terms cannot be added. So it's not like the first example where I could have easily added the 6.2 to the 11.4 or something like that. So we did. You can't add 2.5 to X. And you won't get 2.5x. You're not allowed to do that. So there is nothing over here to do. It's just a single number, it's a constant, just over here. And you cannot add 2.5x. So what do you think you can do? Just look at the formula. What do you think you can do?
Get rid of it. Move the x.
Can't move it. There's only a couple of operations here. You have add, you have multiply, you have divide. You can't add, and you can't multiply, not yet. Well, you can to an extent. But what else can you do? Very good. You divide the what? 7.3 by 2. Okay? You can't go inside the bracket and divide across an addition sign. If you're adding, you're adding. If you're dividing, you're dividing. You cannot divide across an addition sign. You can only divide across a multiplication sign. And if you choose to divide the 2.5 by 2, you're going to also have to divide the x by 2. But dividing the x by 2 is like that. It didn't make a move. Because you cannot get an answer for x divided by 2. So here for random, we're going to say 84 equals 2.5 x sorry, 2.5 plus x. Somebody on the calculator, please, could you divide 7.3 by 2? Pardon me? 3.65. Are you? Good. And I choose to use decimals. I could have used easy numbers and run through this here. But I don't want when the exam comes, my exam, my quiz or whatever, then when they get decimals you find it challenging. I want to give you the challenging part of the math right now. So then what do we do here? What topic are we on in algebra currently? Have we reached distributive law as yet? We haven't? That's fine. We're going to be prematurely exposed to the next topic. Now you're going to be learning in algebra, which I'm assuming is tomorrow's class, that when a number is on the outside of a bracket, you're going to use that number to distribute the inside terms. So the 3.65 will multiply to 2.5, and the 3.65 is going to multiply the x. That's called distributive law in algebra. So once you have a number that is on the outside of a bracket, you're then going to use it to multiply what is on the inside of the bracket. God, have I lost you? Where have I lost you? Here? No, listen to it. We just use the number outside to multiply it inside and how to do it now. It's just understanding that if I see a number outside of the bracket, I am going to use it to multiply what is on the inside. Let's go ahead and do that. 84 equals, on the calculator, type in 3.65 multiplied by 2.5. 9.125 plus, when you multiply a letter with a number, you're going to get the letter and the number. Yes, you are allowed to multiply unlike terms, you're just not allowed to add them. So when I multiply 3.65 by x, I'm going to get 3.65 x. Do we follow? Have I lost anybody? Come on, do your thing. Have I lost anybody? Have I lost anybody? Well, Ali, have I lost anybody who was paying attention? Okay. Now, what do we do here? Our aim is to isolate the x, Brandon. We need to get the x to be by itself. But there's two things preventing us, Shanice, from getting the x by itself. What are the two things preventing us here? The 9.125 and the what? 3.65. We need to get rid of those numbers. So to get rid of this one, we're going to transpose and bring that to the right side, to the left side. So that's 84. It becomes a negative. Why negative? Because when you transpose, it becomes the opposite sign. So 84 take away 9.125 will give us the value of 3.65x. Go ahead, subtract that please. What is 84 minus 9.125? 74 point? Pardon me? 875. So 875, I'll work it out. Equals 3.65x. Okay? And you have seen this before. Final step, guys. Final step. You've seen this before. When a number, or we say a coefficient, is attached to the variable by multiplication, how do you split them apart? You're already multiplying. So how was the opposite of multiplication? Beautiful. So you see 74.875 divided by 3.65 gives you the value of x. What's that, please? X equals x equals? Jada, want to calculate? Pardon me? I'm not hearing you right at the top, clear. 20.51 centimeters. Alright? So that's the process you have to go through in case you throw a question like that on you. Now you're probably looking at it and like, yo, this is wrong, this is hard. It is hard because you're reversing the question. You're going backwards. It's going to be a challenge. And as I said before, a lot of these things here that you're seeing are application. Okay? Application. So that's what you have to go through. I'm going to give you one to try. Hopefully you guys can actually look at the example and replicate the example. Look at exactly what I did in each step and follow that exact step to see if you can get this one right. Okay? Alright, so I'm going to keep the same diagram, I'm just going to change information on the inside. So same diagram. I'm going to call this X, I'm going to call this 15 centimeter. I'm going to call this 8 centimeter. I'm keeping it simple, I'm not using any decimal. So 8, I'm calling this X, calling this 8, calling this 15, and I'm giving this an area of say 125 square centimeters. So area is equal to 125 square centimeters. Alright, so go ahead, use that information, replicate the example that I just gave you, find the missing side, X. So, information here. First thing, trapezium, A equals A plus B divided by times H divided by 2. So the area, as instructed, is 125. You have to decide what A and B is. A and B are the parallel sides. So when you look at the diagram, 2 weeks from now, a week from now, next week, when you look at the diagram, you have to look at the diagram and be like, which of the two sides here are going in the same direction and will never meet? I know that if I extend this and I extend that, I'm most likely not going to meet somewhere, so those two sides could never be the parallel sides. So square it has to meet these two sides. Once you've identified your parallel sides, then you know that you can choose whichever one you want to be A or B. I'm going to choose this to be my A and that to be my B. That's what I want to do. Okay? So my A here is 50 and my B here is X divided by 2 times everything by 8. Once again, just to remind you, touch it. You cannot go inside the bracket to do any form of division. You cannot divide when you're clearly adding. So the only thing that you can do here on this side is to divide whatever number is on the outside by 2. Whatever number is on the outside, just divide it by 2. So you have 125 is equal to 15 plus X multiplied by 4. 8 divided by 2 is 4. And as I said, prematurely being exposed to tomorrow's topic, whatever is on the outside should be used to distribute what is on the inside. So the 4 distributes to X, the 4 distributes to 15. We end up with here with 125 is equal to 15 plus, 4 times 15 is 60. 4 times X is 4X. And naturally then we need to isolate the X. To isolate the X, we simply transpose the 60. So that's 125 equals 125, take away 60 equals 4X. You can't leave out your 125. It comes all the way down. This is 65 equals 4X, and you've seen this so many times over. Once that coefficient is connected to your variable, you're going to divide both sides of the equation by that variable. So 65 divided by 4 equals X. X equals, as you guys are telling me, 16.25 centimeter. Okay? So that is how you approach the reversal aspect of this particular diagram. So look out for that. You might just see one of those next week Monday morning. last two-dimensional figure that we're going to be looking at is the parallelogram, the easiest one of them. Okay, that's the last two-dimensional diagram we're going to be looking at. So hit up for me, area of parallelogram. Area of parallelogram. Did you get that, Jordan? Let me stop. So the easiest one of all, the parallelogram, the calculation for the parallelogram is very similar to the calculation of a rectangle. Okay? But first we need to know what a parallelogram looks like, so that in the future when we see one, we can easily identify it, and then we can know that form relates to this diagram. So the parallelogram, my math teacher at the time, he gave me a very simple way of recognizing the parallelogram. And so the parallelogram, what he said, and I find it very useful, is that the parallelogram is really a rectangle that is pushed out of shape. That's what he said. The parallelogram, this is not definition, but just to pick it up, it's really a rectangle, you know, except that the sides are pushed. Okay, so it's either pushed from the top or pushed from the bottom. Okay, so it's really a rectangle pushed out of shape. But for the parallelogram, pretty easy. Both sides are parallel. Sorry, opposite sides are parallel. And not just that they are parallel, they are also equal. So the opposite sides are parallel and the opposite sides are equal. This is one of the few times you can safely say that parallel lines are equal. Formula is very simple, nothing to it. Area is equal to base multiplied by height. You're going to find that they like to put the height inside here, and at times you'll see they draw the height on the outside here. Okay? So you can have the height in either ways here. Either on the outside or on the inside. Okay? And so it's easy to find this. You can see that there's not much variables in the formula, Jordan. Area is equal to base times height. It's either they're going to give you the base and the height to find the area, or they're going to give you the area and the base to find the height, or the area and the height to find the base. The math is not going to be that challenging. Take this down for me. Take this down for me. Find the area of a parallelogram. Find the area of a parallelogram. Given that its base is 11.4, given that its base is 11.4, and the height is 4.3, and the height is 4.3. If you wish to draw a diagram, my teacher always, my instructor, teacher, my lecturer, always tells me that a picture tells 1,000 words. So some students are visual learners. If you don't draw the diagram, then you can't answer the question. So sometimes you may get a diagram, which makes it easier for kinesthetic learners, whilst some persons, the diagram doesn't make a difference to them. They'll be able to read and interpret. So if it's written in words, if it's a worded problem, then you have to pick up the 3 keywords. Area, 4 keywords. Area, parallelogram, base, height. So for this then, I already have a diagram here. I'm going to use this as my example. We're looking for the area, and we're told that the base is 11.4, and the height is 4.3. So we go on our calculator and we process that calculation. What do we get for our answer? As you work the machine, you just have to confirm. 11.4 times 4.3, anything them say, just confirm it. Somebody confirm that, please. 49.0 square centimeters. Okay, 49 square centimeters. When you leave off the unit of measurement, I am told over the years that CSEC takes off marks. I don't believe it, but I don't think that anyone's going to take off a whole entire mark just because they leave off this. But just to be safe, whether it's true or not, please write your unit of measurement when you're giving the answer. Remember, since that the unit of measurement has nothing to do with the actual calculation process. So you're not going to square the number or anything like that. The unit of measurement is just telling you that it is area or distance. So do not put it as part of your calculation. So the reverse can be done. And the reverse is not very challenging. You can see that there's not much variables. Unlike this one over here, where we had 1, 2, 3, 4 variables to contend with, we only have 2 variables to contend with here. So if I give you the reverse, write this down for me. Determine the height of a parallelogram. Example number 2. Determine the height of a parallelogram. Determine the height of a parallelogram. Determine the height of a parallelogram. Given that its area is 36 square centimeters. Given that its area is 36 square centimeters. Given that its area is 36 square centimeters. And its height, pardon me, given that its area is 36 square centimeters and its base, pardon me, and its base, we couldn't write height so fast.
36.
And its base, given that its area is 36 square centimeters, and its base is 5.2 centimeters, and its base is 5.2 centimeters. All right. Now to escape from the guesswork in math, to escape from the guesswork, you have to do what? Write down your formula. And know it simply. It's like right now, for example, when NJ is doing the question, he doesn't know it. And that's fine. Right? I just know it's simple. It is coming to your next bit. It is, yes, it is no. Writing on the formula doesn't seem necessary. But you see, later on, when we start to do some more advanced topics, where if you don't write on the formula, all hell breaks loose. I have to try to get you guys accustomed to the idea of writing formulas down. Because when we start to do matrices, and we start to find singular matrix, and find the values inside the matrix, and then we start to do functions and relation, where you're finding the inverse function, those kind of stuff. When we're doing those kind of things, it's going to be imperative that writing on the formula is going to be your saving grace. So get used to the idea that once you're doing the reverse of the question, practice to write down the formula. In my YouTube videos, you'll hear me say it every single time. I never ever fail to write down my formula. So once again, area is equal to base times height. What did they say that the area was on? 36. So 36 goes underneath the A. Since, remember, do not put the centimeters squared and do not square the 36. And that is equal to, did they give us the base? 5 point. And the height is unknown. The height is, because they say find the height of a parallelogram. So looking for the height. So we've seen this again and again. Now bring over. We're going to divide by 5.2. Don't use that word bring over. Bring over. Normally we use it when we're adding or subtracting. So when we're adding or subtracting, we carry over. So when we're dividing or multiplying, we balance both sides of the equation. But as I said, Shanice, if using the word helps you to remember, if you're going to say bring over, make sure you bring it over as division. Alright? So I'm not stopping the language. So 36 divided by 5.2 gives us h. Talk to me. H is equal to 6.9 centimeters. Right? When you find distance, it is centimeter. When you find the area, it is square centimeters. Alright? Nothing much to that. Very, very simple. Not too tough. Okay. And that really brings us, or that closes the chapter of two-dimensional shapes. Let us do a confirmation. Let us do an oral confirmation. Have we done the square? Forward and backward? Have we done the rectangle? Forward and backward? Have we done the circle? Area and circumference? Forward and backward? Have we done the parallelogram? Just did forward and backward? We've done the trapezium. Forward and backward? We've done the triangle. Well, we didn't do the forward and backward for the Heron's formula, but we did it for half base times height. And we didn't do it for the other one because it doesn't really come up all that often. So we have covered all of the two-dimensional shapes. What do we do with this information? Does it end here? Here's where I find that lots of my students get lost. They learn math in what is called a vacuum. So once I say the end of the chapter, what you guys mentally do is that you close out the square and you think that this particular type of math is not applied elsewhere. You have a next guest coming. All of this information is going to be needed for chapter 2 of measurement, which you're going to be introduced to because we don't have a lot of time left. So I'm just going to give you the definition, or I'm going to introduce what's coming up next, which is my next Wednesday's class. I'm going to introduce what comes up next. Sure. And then from there, we'll just pick up from where we left off. Alright? Alright, good. So our next chapter is going to be volume of prisms. Volume of prisms. I'm going to write that on the board. Volume of prisms. It's just an introduction. We're not going to do anything. We're not going to get into the formulas. We're just going to be introducing it. So we're looking at volume of prisms. And so you're seeing two words that I'm going to assume that you guys probably do not know what they mean. Volume, for some persons they know, and prisms. What is a prism? What is volume? Let's define those. We're going to define it. Volume is the total capacity. Volume is the total capacity that a three-dimensional figure occupies. That a three-dimensional figure occupies. Volume is the total capacity that a three-dimensional figure occupies. So another name for prisms are called 3D figures. Full stop. The unit of measurement for volume is, the unit of measurement for volume is, the unit of measurement for volume is cm to the power of 3, cm cube. Cm with a little 3 at the top, cm cube. That's the unit of measurement. So we're no longer dealing with cm squared. We're now moving on to cm cube. The cube suggests the amount of dimensions in the diagram. Now when we talk about the word dimensions, what we're looking at is length, width, and height. Length can be interpreted as being, let me see, height can be, depending on the perspective at which you're looking at the diagram from, can be interpreted as depth. Now, height, can I borrow your Brandon? Can I borrow your bottle? Okay. So here we have a bottle. Okay. And so, Jada, when you look at the bottle, you're looking at the height of the bottle. But if you were to put the bottle down and stand over the bottle, you'll be looking at the depth of the bottle, how deep the bottle is, or how deep the glass is, or how deep the barrel is. So depth and height is relative to the perspective at which you're looking at the three-dimensional figure. Okay? Width is sometimes referred to as breadth, as BR is bread with a TH. So if you see the word breadth, don't think it's something you've never learned before. It's just another way of saying width. Alright? And length is length. Right? Once the object is lying down, it becomes a length. Length can also be considered to be height. Again, if you look at the bottle here, it has a height. But if I take the bottle and I turn it sideways, the bottle no longer has a height. The bottle now has a length. So this becomes the length of the bottle, because the orientation of the bottle has changed. Yes? So height, length. So we can use the words interchangeably depending on how the orientation of them proceed. And just to wrap up this session here, what do we refer to as prisms? Do I see these things in real life? Every day. This is an example of a prism. It's three-dimensional. It has a height, it has a base, and it has a circumference. Okay? Or it has a radius. Your phone is a three-dimensional prism. In actuality, your phone is a very flat cuboid. Okay? Box juice is an example of a prism. It's an irregular prism, but it's still a prism. Okay? Two different shapes. If you look at the front of the box here, you realize that at the top part of the box here is a triangle. And at the bottom half here is a rectangle. So it's what we call a composite prism. Two different shapes make up this prism. A loaf of bread, uncut, unsliced, is an example of a prism. A loaf of bread, to some extent, can be considered as a semicircle drawn on top of a, you don't know what bread shape, right? Something like so. So if I were to like construct a prism, you could consider this to be a semicircle and this to be a rectangle. Right? Tissue roll, a barrel, a drum, anything at all that you can hold, feel with your hands is a prism. Now in our next session, we're going to dive a little bit more into different types of prism. We're going to be drawing them and looking at the formulas of how to calculate volume. Alright? So that is it. If you want to review this class, you can watch the class. I started uploading live classes on my channel. So if you want to review this particular session, you can view it tomorrow. You can view it another day. Alright guys, take care.